Okay, so I'm working 7-4, number 17, and we're trying to find the values of x and make this a true statement. Solve this equation, and it's a trigonometric equation. So we have 2 cosine squared x minus 3 equals 5 cosine x. So I'm doing a u substitution where I say u equals cosine of x. That way we're going to kind of separate our trig function from the quadratic equation. And solve a quadratic equation first, then go back and deal with the trig function. So I can rewrite this as 2u squared minus 3u equals 5 if I substitute u for the cosine of x. And I want to bring everything to the left side, so subtract 5u from both sides. And I have 2u squared minus 5u minus 3 equals 0. So I'm going to do 2 times negative 3 is negative 6. Are there factors of negative 6 to add to be negative 5? Well, negative 6 and 1 works for that. So we would have 2u squared minus 6u plus u minus 3 equals 0. So 2u squared minus 6u plus u minus 3 equals 0. And we can factor out of the first pair 2u. We'd have a u minus 3. Out of the second pair, all I could really do is pull in a 1. So we would have 2u plus 1 times u minus 3 equals 0. So 2u plus 1 equals 0 means 2u equals negative 1 and u equals negative 1/2. U minus 3 equals 0 means u equals 3. Okay, so we have to go back and say we know that u equals cosine of x. So that cosine of x equals 1/2 and cosine of x equals 3. Can cosine of x ever be 3? The answer is no. There's no solution for that one. But cosine of x can be negative 1/2. If we think about what arc cosine is going to give us, so we'd say arc cosine of cosine of x is arc, I'm out of room there, arc cosine of cosine of x is arc cosine of negative 1/2. So x equals arc cosine, and recall that arc cosine returns values from negative. No, I got that wrong. Arc cosine returns values from 0 to pi. So in the first quadrant, cosine is positive. In the second quadrant, cosine is negative. And recall, all students take calculus. Cosine is positive in the first and fourth quadrants. It's negative in the second and third quadrants. So in this case, it's going to return a value over here in this quadrant. So our negative, when's cosine going to be negative 1/2? Didn't draw it quite right. More like that. X is going to be arc cosine, which is also called cosine inverse, of negative 1/2, and that's going to be 2 pi over 3. So if this is 2 pi over 3, we also need to find where else it's going to be. Now I want to point something out. This part's 2 pi over 3. The reference angle here is going to be pi over 3, because 2 pi over 3 plus pi over 3 is pi. Likewise, this reference angle is also pi over 3. But then the question comes up, what is the measure from here all the way down to there? That's going to be pi plus pi over 3 to give us 4 pi over 3. And why do I go for the third quadrant? Because that third quadrant is another quadrant where cosine is negative. It's negative in the second and third quadrants, so I have to find the equivalent angle down there. Therefore, x is going to be 2 pi over 3 and 4 pi over 3, but it's not just there. It'll happen every 2 pi. I can go 2 pi later. I can go around and around. I mean, if this is my solution here, it's there, it's going to be there again, it's going to be there again, it's going to be there again, also be there going backwards, going backwards, going backwards. So I need to say plus 2 pi n, or 2n pi, I think is what the book does, plus 2 pi n. So those are the solutions to this problem. I hope that helps.